All right, Sean Carroll is joining us now. Sean, I don't really know how to adequately introduce you because I feel like you're an ambassador for quantum physics and asking deep questions, which I think is great. But you're also a teacher. You know, you teach at Caltech still, right?
Well, actually, mostly at Caltech, I do research.
Oh, okay.
That's my job at Caltech. So one of the reasons why I do so much outreach and videos and book writing is because I'm not teaching at Caltech. So that's what takes up that part of my brain.
Gotcha. Okay, so that's what was the impetus for starting this lecture series of like the biggest questions in the universe, which by the way are fantastic. I love that you can draw and explain with pictures while you do it. I think it's fantastic.
Yeah, so I have these videos, the biggest ideas in the universe. This was a quarantine project. Everyone has their quarantine projects, and I could see it coming, the quarantine. So I've been meaning to do more video for a while, but there's other things to do, right? One gets busy and so forth. So I thought this would be a good excuse, and I ran out and. Just before the stores closed, I bought a green screen and a video camera and learned to do it. And, look, it was not easy. You can see the improvement in my skills over the first few videos as I figured out how to do the green screen correctly, etc.
That's very good, and you have good enough handwriting that I can read it afterwards, and that I know what it means.
If I slow down, I do. When I'm writing for myself, it is not illegible to anybody else. Trust me.
I got an opportunity to watch your video on entanglement, which came out I think 5 or 6 days ago, and I think it's a great kind
Last
of
week, yeah, that's right.
yeah, it's a great like kind of introduction into the double slit experiment and measurement problems and how all of that works and how our interaction with the physical universe changes its nature in a lot of ways.
Yeah, quantum mechanics is hard. That's something we can all agree on. The opening line of my last book, Something Deeply Hidden, is you don't need a PhD in theoretical physics to be afraid of quantum mechanics, but it doesn't hurt. And even professional physicists, even though they use quantum mechanics all the time, and it's spectacularly successful theory, it's clearly the best insight we have on how nature works at a deep level, we don't claim to fully understand it. And that's unlike other theories in physics, which we do claim to understand. So it's a bit of a sticking point, I think. Why don't we understand it better? So things like the double slit experiment, where you send an electron through two slits, and depending on how you observe it, it acts like a wave or it acts like a particle. These get to the heart of the mystery of quantum mechanics.
Right, and just to be clear, we know that it's a wave because of the interference pattern that it leaves, right? It's like we can see the residual effect of what it is. That's why we know what it is.
It's one reason why, the double slit experiment is very interesting because it was explained and used as a thought experiment long before it was actually done as an experiment. It was one of
Yeah.
those things where I don't know who started the double slit in the quantum version, but I know Richard Feynman basically popularized it. And he understood quantum mechanics, and he figured out that here was a way to sort of summarize what the biggest mysteries were in one nice little experiment. So that was long before we had the technological ability to actually do it. I mean, the idea that electrons are waves goes back to, the 1920s, and people were trying to understand why atoms were stable, why electrons didn't spiral into the center of atoms, and this wave idea helped us understand that.
One of my favorite things Richard Feynman ever said was the nature of why questions. In order to answer a why question, you have to allow for something to be true. And I would imagine for you that is very difficult, is you have a very high standard of what you allow to be true in your field.
Well, it's a very important point because when I'm talking about things like quantum wave functions or fields pervading the universe, people often want to know, well, what are the fields made of? And
Yeah.
I have to say, they're not made of anything. They are the things out of which the universe is made, right? There is a bottom to this series of questions. Well, what's that made of? What's that made of? What's that made of? There's a bottom level there where you say, like, this is the stuff that the universe is made of. They're not made of anything at all. And some people, just out of their intuitive way of thinking about the world, they reject that. They're like, no, that means you don't understand it if you can't tell me what it's made out of. I'm like, what do you want me to say? It's made out of, bells and whistles. There's nothing that it could be made out of. It's what everything else is made out of.
Yeah, and so I guess the diversion of the two ideas becomes then the implication is that reality branches or forks or whatever you want to say, or that there are some hidden variables in that are affecting the wave function that we are not aware of. And I think on your entanglement video, you kind of discussed like, hey, look, entanglement, the way that it works is if you look at it from a many worlds perspective, it's plug and play. It's a systematic, easily, like it works. And then
Yeah.
with hidden variables, you're just like, I don't really know what I can do with that.
Well, so the fundamental dichotomy of quantum mechanics is that things like electrons or other subatomic particles, where their quantum behavior is front and center, they act like waves when we're not looking at them. And then they act like particles when we are looking at them. And so that's the fundamental mystery. Why in the world should us looking at something make any difference at all to how the world works? And so in the many worlds version of quantum mechanics, you say what it means to look at something in this context is to become entangled with it. So you have a little electron, you observe it, that means you interact with it physically, and you become entangled with it, which means the electron could have been in a superposition of being here, being here, being here. There's a little bit of it in all those places. When you look at it, you only see it one of those places. And many worlds says, well, that's because there's now many copies of you. One that saw it here, one that saw it there, one that saw it there. That's the clear prediction of the underlying equation, the Schrodinger equation. Other people are going to say, well, I don't like that prediction. That doesn't make sense to me. That doesn't fit the universe that I experience. And therefore, I'm going to change the theory in some way. I'm going to either add more variables or change the Schrodinger equation or reinterpret everything from a fundamentally different point of view. All of these are options that are on the table when it comes to trying to understand quantum mechanics.
So is there an answer to that question, or is it just something that we have to accept, that the nature of it is if we observe it, it changes it, and that's just true, and we just have to accept it?
No, I think there's 100% an answer to it. I mean, this is the big progress that we've had in the last 50 years in the foundations of quantum mechanics. In the old days, in the bad old days, when we didn't understand quantum mechanics very well, it was absolutely legitimate to wonder whether or not human agency, consciousness, perception, something like that, played an important role in understanding what quantum mechanics was really all about. Because we had these rules that said when you observe it, something happens. These days, we know better because we have very explicit mechanistic theories, like many worlds, but also hidden variables, objective collapse models. There's a whole series of different models, none of which have consciousness or perception or human beings in them at all. They play zero role in there, okay? So the problem is we have more than one. Like if we only had one model that worked that way, we'd be happy. We would think, oh, maybe we're on the right track. The problem is we have a number of them, and it's hard to decide which one is correct. But one lesson we can absolutely draw is there's zero reason to think that human consciousness has anything to do with quantum mechanics.
Yeah, right, sure, no question. So, like, I think my question is about the nature of observation itself. Just that we are observing things and therefore it changes it. Seems like a little bit of like the prime directive out of Star Trek, right? It's like don't interfere with other civilization kind of things, but observe them. And I wonder if, like, why those two things are so intrinsically linked, that the second that you observe something, it changes it. And what does that tell us about the nature of experiment in general? Because it seems pretty core to like the problem we're trying to solve is figuring out why our understanding is limited to begin with.
Well, yeah, I think that it's important to recognize that the way in which observation does disturb the system in quantum mechanics is special. It's not just another example of the general feature that when you look at something, you might disturb it, okay? Like when you try to take a picture of your friend, they don't look as good, or they look better, who knows? They smile when you point the camera at them. That's not what's going on in quantum mechanics. It's something much deeper and more profound than that. The difference is that it's not just that you're interacting with the system. Of course, when you interact with something, when you shine a light on it, maybe it changes. So maybe observing it changes in that way. That's sort of obviously true. But in quantum mechanics, entanglement gives you another thing that can happen. Not only are you interacting with it, but your state is becoming entangled with the other one. And that's the fundamental thing about quantum mechanics, is that there's not a separate state of you and state of the electron and state of Alpha Centauri or whatever. There's one wave function, one quantum mechanical state that describes the whole universe at once. So you can become entangled and therefore related to the system you're looking at in a very, very important way. That's new to quantum mechanics. It's not just another example of, oh, I knocked my elbow on something and it fell down. It's much deeper than that.
So when does the pavement on physics run out, so to speak? Where is it? The Higgs is like the last thing that we've discovered. That's it.
Yep.
And then I've heard people say this. I think Eric Weinstein said this on Joe Rogan's podcast. It was maybe a couple of years ago, but he said it feels like we're almost at the end. And he said that it's made everybody really nervous. But then other people will say, like, there's no possible way that we're at the end of discovering things. So I'm curious, how that, where are we at, I guess?
Yeah. I mean, it's a really good question, and it's a subtle answer. So you have to like take care to listen to all the parts of the answer. On the one hand, we're definitely not done. We're not finished. Okay. We're not near the end. And we know that because there are huge gaps in our current understanding. We don't know what happened at the Big Bang. We don't know what happens inside black holes. We don't know what the dark matter is. Okay. I mean, there's puzzles, both sort of things that seem unnatural to us and things that we just don't understand at all. So clearly we're not done yet. Okay. We can't reconcile quantum mechanics with gravity. There's big questions that remain unanswered. On the other hand, if you look not at the entire universe in all of its splendor, but at our everyday lives, okay? You and me, and for that matter, let's expand our everyday lives to include everything we see in the sky, right? The stars, the planets, and everything like that. We can explain that. We have laws of physics that do a very, very good job of fitting all of that data. We do not have a big experimental discrepancy between what we predict with our current physics and what we observe in our telescopes and microscopes and so forth. And that's probably going to stay true, right? When it just comes to the physics of your everyday life, the things that are happening in your body, we have very good reason to believe that we're done at that. So I think it's very, very important to sort of emphasize both of those things at once. We're done understanding the physics of what you're made of. We're not done understanding the physics of the wider universe.
Sure. What do you think is, well, maybe that is the answer. Maybe the more dangerous frontier, so to speak, is the big stuff, like the stuff that's enormous as opposed to the stuff that's really, really tiny. Because the tiny stuff, it seems like we're at a point where a stopping point in terms of our ability to get more information, if there is more information to be gotten.
I don't know. I think that I would suggest patience when it comes to these things. Like, we're a little spoiled because the 20th century was just extraordinarily amazing time of progress in physics. And if you want to be careful about it, the first third of the 20th century was a time of extraordinary progress in physics. We invented relativity, we invented quantum mechanics, we invented quantum field theory, we discovered the universe was expanding. We found out the Big Bang, like just an amazing amount of progress packed into a very, very short period of time. So much progress that the next 30 years, the second third of the 20th century, was basically devoted to cleaning up the implications of all that, to understanding particle physics and the Standard Model and astrophysics and black holes and things like that. And now progress is a lot slower than it was back then. But that's not our fault now. That was their fault then. They got really, really lucky to be born at a time when physics was just changing with a revolution every 2 days.
Yeah. Well, so I think one of the weird things to me that has kind of emerged out of this is the I don't know how to say it. It's a on again, off again relationship with time that physics seems to have, because some people like to remove time from the physics equation, so to speak, or at least not. And you did a good job of explaining this, I think, in your video on time, where it's some studies, like you're a block universe person, and some physics does not acknowledge the difference between tenses of time, past, present, future.
Yeah, I mean, the equations of physics that fit the data very, very well seem to imply that there's nothing special about the present time. The laws of physics, in other words, are invariant under what time it is. They don't care what time it is. There's still the laws of physics. They're still telling you the same thing. So in that sense, the past, present, and future are all described by the laws of physics in the same exact language. So you can say, maybe the right way to think about it is that the past, present, and future are all equally real. They should be treated by we human beings as being on the same footing. And I have a feeling that I'm in a certain special moment called now, but I think that at every time that I exist, all of the different versions of me, the version of me 5 minutes ago and the version of me 5 minutes from now, all think that they're living at a special time, right, called now. So therefore, I think it does make a lot of sense to be a block universe person, to not prejudice the current moment in any special way. But then that leaves you with a lot of questions. This is one of those things where there's questions that arise because you understand something better. Like, Aristotle didn't have to worry about, why do I feel like I'm flowing through time? He would have said, you just do. What do you mean? Why is that a question?
Yeah, right, yeah.
Why can you remember the past but not the future? He would have said, well, the past has already happened and the future hasn't happened. What are you bothering me for? I have important philosophy to do. But now, with our better understanding of the universe, it becomes an interesting question to ask why the past and future seem so different to us if our equations treat them the same. And we have very good ideas about that, but it's not settled. And it's like you say, it has led some people to suggest that maybe time itself is not fundamental. Maybe it's just an emergent approximation. Maybe the one true laws of physics don't have time in them at all. And that might be true. I'm pretty open-minded about that. I don't claim to know the answer.
Yeah, I think one of the problems, and maybe this is why physicists have or some physicists have a problem with time, is that our observation of things, our consciousness seems to be reliant upon its passage. Just to simply ask questions, time has to pass for words to come out of my mouth and for processes in my body to take place and things like that. So when people remove it, it seems like it makes it easier for their equations to work sometimes, and things like that. So I wonder if, because it's like, well, it gets into some strange questions that are murky. It gets into dark waters if we get too deep into time as essential.
It does. And, like I said, when I say that I'm agnostic about what the truth is, like, it's hard to find people who are agnostic about this. People have very strong opinions about time.
Yeah.
I noticed this, the first two books that I wrote, first two trade books, popular books, one was on the nature of time, called From Eternity to Here, and one was on the Higgs boson, which we already mentioned, right, called The Particle at the End of the Universe. And interestingly, like the Amazon reviews and just the chit chat on Twitter, etc., were much more positive for my Higgs boson book than they were for the time book. And when I did the time video for the biggest ideas in the universe, it has been the most viewed video in the series, but also like the sort of percentage of likes is a little bit lower than the others. And I think that the reason is, when you talk about the Higgs boson, most people on the street don't think that they understand the Higgs boson better than the experts, right? Like, they're willing to take what the experts are ready to tell them. But when it comes to time, like, there's a lot of people out there who think they're the expert, who think they have a better understanding than you do of it. So, I mean, they might just be crackpots, or they might be, very sensible people who say, look, here's what's most important about time to me, and you're not talking about that. Therefore, I'm annoyed and irked by your presentation. So time is, one of the favorite anecdotes is that the word time is the most used noun in the English language, and it's the most used noun in other languages, generally speaking. So time is really, really important to us, and yet we don't claim to understand it at a deep level. We have a superficial understanding of it that does very well, but at the deep level, I would want to be open-minded and agnostic about it. I think that there's a lot of options on the table.
Yeah, I mean, we know certain things about how the passage of time can change, right? Because we've done experiments with clocks. I mean, just like different elevations that we can literally, I mean, even from like, I think the table to the floor, if you've got a good enough clock, you can see a difference, right?
Oh yeah, no, like I said, when I say we have a superficial understanding of time, don't get me wrong. We're really, really good at measuring time using it, just like quantum mechanics, right? We're really, really good at predicting things. Einstein basically gave us, in the theory of relativity, our modern understanding of how time works and how it's part of space-time. And it's not, there's a wonderful book out there called Einstein's Clocks and Poincaré's Maps by Peter Gallison, who is a professor of the history of science. And he points out that it's not a coincidence that when Einstein invented the theory of relativity, he was working as a patent clerk in Switzerland in the patent office, because in 1905, the hot thing to patent were clocks. And the reason why is because Europe was being unified by people traveling in trains. Okay, you could get to another city in a relatively short period of time. So it became important to synchronize the clocks so that you knew when your train left and when your train arrived, right? And so Einstein was thinking about these very down-to-earth issues, how you synchronize clocks across different parts of the world. And it helped him realize that time wasn't universal. The time was not just once and for all given to us, but that different people moving through the world in different ways, carrying wristwatches with them, might measure time differently. And using that insight, he really came up with these wonderful theories that still serve us very well today.
So are there places in the universe that we can observe where time is moving in significantly, like dramatically different ways, more so than what the differences we can see?
Depends what you mean by the universe, but not here on Earth. There's two ways that you can make time behave funny, or at least, from the point of view of the outside of observer, behave funny. So one thing I should say, very important, if you personally travel near the speed of light or to a black hole or something like that, you don't see anything funny going on at all, because you don't see like the watch hand slow down, okay? Yeah. Because you and the watch slow down in exactly the same way, right? So you don't ever feel time moving at any rate other than 1 second per second. That's what you would personally experience. But in those two circumstances, when you either travel close to the speed of light or you're near a very strong gravitational field, so that means either a black hole or a neutron star or just far away in the universe, then there can be this change in how time gets measured from your point of view. And we can absolutely see that effect experimentally. We see it in the explosion of stars very, very distant from us, the time it takes their light to get bright and then get dim again is different if they're very, very far away and the universe is expanded in between us. Near black holes, time changes. We haven't measured that directly because we don't have any clocks falling into black holes, but we need to take account of it when we make predictions for measurements that we do, like the gravitational wave detection at the LIGO Observatory that we did a few years ago, won the Nobel Prize. So the fact that time changes dramatically is true. And of course, here on Earth, we can do super duper precise experiments to see it change just a little bit.
It's interesting when you say the speed of light and that phrase. I think especially for people who are my age, I'm 33 or younger, my mind immediately goes to interstellar travel. We're going to one day be able to travel the speed of light. But I also remember when I was a kid, just a short anecdote here. We were at a family get together, or family reunion picnic, and my uncles were talking about quantum physics. My uncles were really into this stuff. They loved it. And he gave me a problem. He's like, if a pitcher could throw a baseball the speed of light, how quickly would it get to home plate, and what would happen? And so basically, the way he had explained it to me is that the baseball would be like the size of the sun, like it would be enormous. And I wonder if that's true. It's a weird thought experiment, obviously. But right. What happens to matter when it travels that fast? Does it explode? Does it get really big? What happens to it?
So I think he got it backwards. Sorry to say.
Okay.
What actually happens from the point of view of someone, standing on the baseball field. So again, from the point of view of the baseball just looks like the baseball. It doesn't look any different. It always looks the same. But from the point of view of you standing next to it, if you're the batter, okay, there's something called the Lorentz contraction. What actually happens is something, if it's moving in this direction, something squeezes in that direction and gets smaller, okay? It has more and more energy because it's traveling fast, close to the speed of light, but it gets smaller and smaller in this direction. It stays the same size in the perpendicular directions. So the baseball would look like a pancake, a very, very, very thin pancake coming right at you. But it would have so much energy that if you tried to hit it with your bat, you would explode. If you want something to explode, that's how to make it happen. The baseball's not going to explode.
That kind of, obviously, I know that there's a theoretical limit because they know how fast human beings can travel in space safely. But, just to kind of entertain the idea of our Hollywood sense of traveling really fast so that we can have interstellar travel be possible. going to other places. I think I think I saw a news report about like the closest actual habitable planet to Earth is something like 2,000 light years away or something like that. It's like really far away, so obviously
It's far away. I don't actually know the number either, but it's far away. Yeah.
it's really far. So it would take longer than humans, at least recorded human history for sure, has existed by a long shot. So it would take a long time to get there unless you could travel faster. And I wonder if that's maybe just a pie in the sky virtue of like, what, that's something to aspire to, certainly. But I just don't know if the reality of it is as plausible as science fiction has made it.
So here's my perspective on this. Don't want too hard to be able to travel faster than the speed of light, because you're going to be disappointed. That is not allowed by the laws of physics. But there are other things that are allowed by the laws of physics, such as increasing human lifespans, right? You say, well, the closest habitable star is 2,000 light years away. So if you travel at 10% the speed of light, from the point of view of people here on Earth, it would take you 20,000 years to get there. And you go, oh my God, that's way too long. But if your lifespan were 1,000,000 years, then 20,000 years might not be too long, right?
Yeah.
Or even if you could just put you into cryogenic slumber and then wake you up when you get there at the end of the day. Those things are very difficult, impossible to do with current technologies, but it's not impossible to imagine future technologies that could easily do them, right? So if you really want to get to the stars without violating the laws of physics, don't worry about traveling faster than the speed of light. Just try to live long. That's much more plausible.
Right. Yeah. Live a lot longer. And, that's one of those things that, consciousness is kind of at the heart at, because people want to live longer. They have a kind of a need to continue living, which I think maybe can create a lot of stress on people because they know that there's an inevitability about death. I mean,
Yeah.
I think we're batting 1,000 on death in the human race so far.
Yep.
So,
the universe has no special secrets about that. Death does seem to happen to us all. Yeah.
yeah. So, I mean, people want to live longer and extend human lifespans and use technology to do that. I'm just curious about what you think that technology looks like, because it seems like being an organism and being inside of a physical, organic body is essential to being a person. So the idea that you could submit your consciousness to a computer in which it could live, to me, seems dubious at best.
Yeah, so I have mixed feelings about that. I do think that what we call consciousness should be anyway independent of what makes it up, independent of the substrate on which it is constructed. So I have no trouble whatsoever imagining that computers, sufficiently advanced artificial intelligence, could qualify as conscious. But you're right that the natural thing to think is that it would be very different than us. It's not in a body. It doesn't get hungry, like, right? An AI program never gets irritable because it's been up too long or anything like that. You could imagine trying really hard to reproduce all of the weird ways in which the body affects our minds in a computer. I'm not sure why you would, but you could try, right? So there's no obstacle to doing that in principle. Whereas the biological body, it's very important and very interesting to think about how we could extend it. I've done podcasts on this on my own podcast, Mindscape. I talked to Colleen Murphy, who is a professor at Princeton, who works with these little nematodes. These are tiny little roundworms that are biological model organisms, and she can make them live for 3 times their ordinary lifespan just by changing one gene inside them, right? And part of it is the realization that biologically, our bodies are not trying to live forever, right? We live for a few decades. We have our reproductive usefulness, and then we're useless, evolutionarily speaking, right? So nothing in biology, nothing in evolution or anything like that has tried to make our bodies live forever. So we can sort of step outside that and say, like, okay, let's think about why aging happens. Turns out to be extremely complicated, a lot of things going on. Our DNA, when it gets copied, gets sort of gently degraded every single time, or most times anyway. And so it's hard to just, that's why it's hard to clone things. Cloning something from an old person is different than from a young person. But maybe we can imagine ways to fix that. The as good as the 20th century was for biology, the 21st, or for physics, the 21st century might be just as good for biology.
You did a Mindscape podcast with L.A. Paul a while back, and she writes about transformative experiences. And this is one of the things that really I think scares a lot of people about just all of what, figuring out the question of what's going on, is that it seems as though, at least from what we can see in the past of human history, is that the whole human race or species kind of went through a transformative experience. We got really smart really fast. And nobody seems to know directly what the cause of that was or why, but it's here. And now everybody's like, oh, we can make tools and we can do all kinds of really interesting things with our environment, and we can measure things really far away and that are also really tiny. And so just like that emergence of understanding of things, at least it's made me impatient a little bit as a person. I feel like the whole human species is a little impatient with what's next? What's the next thing that we need to understand to get to the next plateau of whatever,
Yeah, no, I think it's very obviously true that we're in the middle of tremendous changes at a very rapid time scale. Martin Rees is another person I did a podcast with on extreme risks that human beings have posed to themselves. Before 100 years ago, it was simply impossible to imagine the human race wiping itself out. We didn't have the ability to do that. Now we have the ability to do that in a number of different ways, actually, right? And so are we ready to deal with that? And even before you worry about, wiping people out with nuclear bombs or biological weapons or anything like that, I think you correctly mentioned how we're transforming ourselves, how we're becoming different in ways that we can't anticipate. Lori Paul's point about transformative experiences is not just that, they're big experiences and it's weird. It's that it is literally impossible to know what we should want now, given that our wants might be different in the future, right? If I know that I will be different and I will like something, should I do it even though I don't like it now? And, she uses examples like being a vampire or something like that, right? Vampires seem happy. I don't want to be a vampire, but if I were a vampire, maybe I'd be happy doing it, right? That's the ways that we have of figuring out whether a transformation like that would be a good idea or not is just are inadequate to the task. And so socially, as far at the societal level, same thing, should we give up on work? I just did a podcast just this week with John Danaher, who says, yes, we should stop working. We should hand over all of our work to robots and become artists and musicians. Okay. That's one point of view. And, it's not that work would be outlawed, but it would be optional. It wouldn't be tied to your income or something like that.
Yeah.
And it's the kind of thing which we can now contemplate for the first time. Not that we should do it or should not do it, but we can imagine doing it, and it's hard to know whether it's the kind of a good thing. Uploading to the Matrix is another example. There's all these things that would be radically transformative that we were going to need to face up to.
Yeah. You mentioned, giving up on work. I think that's a really interesting concept because it's hit people just how useful $1,000 a month would be here in the United States during the pandemic. And so Andrew Yang and UBI have been huge topics with people. And it's interesting, you look at the way that human hierarchy is built a little bit in society, and you've got a lot of people down here at the bottom who, a lot of them are, it's like starvation. Bottom really means I can't make ends meet, and if we could, as a society, maybe not change the hierarchy, so to speak, but bring the bottom to a point to where it's like everybody can eat, everybody can do all this stuff. What is the potential of human intellect at that level? Because I think instead of the criticism of it is that it would make people complacent and lazy, lounging around, being artists and all that. I think people would be more productive. I think they would come up with new ideas in droves, exponential new ideas. I think theoretical physics is a perfect place for people. It's a place people should be spending their time, as opposed to being, instead of laboring against something, build your wealth through equity and then focus on quantum physics for 20 years or whatever and come up with some ideas.
Yeah, look, I completely agree, actually. I think that we're a little backward in our thinking because we've lived in a world where you had to work to make a living, and that was a virtuous thing. And one of the things that I talked about on the podcast with John Danaher is the idea of the moral hazard associated with not working and therefore just becoming a lazy bum. And so I think that there's two responses to that. One, as you said, most people do not become lazy bums. Most people would do interesting things, right? It's sort of not really in the human makeup to just sit around and call that a successful life. We want a little bit more than that. And the other is, look, if 10% of people want to sit around and be lazy bums, so what? What's the worst thing? What's the problem with that? Like, what's so great about your life that you're judging someone else's life? If someone wants to sit around and play video games all day and they find that fulfilling rather than making $1 billion at a tech startup, what's wrong about that? If the society has the resources to do it, then I think that there are worse things than letting people live the lives they want to live.
Sure. And, consciousness, that's one of the hard things about consciousness, is that everybody has different ideas about what it is and at what levels it exists and all of that, because we can only really subjectively, or I should say objectively, know that, like, it's that I think, therefore I am premise,
That's the claim. Yeah, that was Descartes' idea. That's the one thing you can know. Even that is easy to doubt if you really want to doubt things. But we
Yeah,
do. I would be in favor of thinking that we do exist. Yes.
yeah. So but there's people like David Chalmers. I think Robert Lawrence Kuhn did a video recently about a consciousness seminar or a convention that they do in Arizona, and
Yeah.
David Chalmers was there, and they were talking about panpsychism and
Mm-hmm.
how consciousness, it's the idea that consciousness exists in every single thing at every single level of the universe, which is a bold statement. It's a simplistic solution, but I don't I don't think we have any evidence, or really even there is a possibility of measuring evidence of that being true.
Yeah, I had David Chalmers on my podcast also, and we briefly mentioned panpsychism, but then I had this guy named Philip Goff, who is one of the young leaders of the panpsychist idea. And so we really delved very deeply into that. So I strongly think we have perfectly good evidence that it's wrong, that electrons are not conscious in any useful way of thinking about it. And that doesn't surprise me at all. I think that you need to have an appreciation for the emergence of collective phenomena. There are things that can happen when a whole bunch of little things come together to make a big thing that are not inherent in the little things themselves. Or at least you wouldn't notice them there. They're not. It doesn't make sense to talk about. You can talk about water being wet, and water is made out of electrons and protons and neutrons. But it makes no sense to talk about an electron being wet. Like, what does that even mean? The wetness emerges at the collective level when you have many, many, many of these little particles. There's no trouble believing that something like consciousness is the same way.
Okay, so where are you at with consciousness? What do you think it is? What do you think do you think we'll hopefully find some physical correlation to the process that we can replicate, or how do you think that's going to work?
Yeah, where Chalmers really became famous was this thing, his thoughts about what he calls the hard problem of consciousness, which I think it's a good framing, but I don't think it's a hard problem. So his idea was there's our consciousness studies in the neuroscience departments at laboratories and universities around the country, which basically look at the brain and they try to say, like, how does the brain interpret color, or how does it keep our balance, or how does it remember things? And these are all important parts of being conscious. Even how does the brain imagine the future or something like that? But he says those are the easy problems. Like, no one thinks that it's hard to imagine doing any of those things in a brain. A computer can do all of those things perfectly well. But he says that there's the hard problem, which is the first person experience of consciousness. So, like, not only am I seeing something that is red, not only are certain neurons flashing in my brain saying, oh yes, you're looking at something that's red. He says I'm experiencing the redness. I can experience sadness, happiness, redness, wetness, coldness, all these things. There's something it is like to be experiencing these things. And he says that, number one, is much harder to explain in purely physical terms. And number two, is much harder to imagine a computer having or anything like that. So that's what he thinks is going to be a sticking point for people like me. I'm on the physicalist side of these things. I think it's just electrons and protons and neutrons all the way down. I don't think there's anything special about the experience of consciousness. So my prediction is that the hard problem, that what Chalmers calls the hard problem, will just go away. Like, rather than some brilliant philosophical insight or some brilliant neuroscience experiment going, oh yes, the redness of red is located in this neuron. Rather, what's going to happen is, as we understand how the brain works better and better, then what we're going to find is that for every single thing that you and I would call a conscious experience, there's something specific happening in the brain. And we can sort of predict it and understand it and see how it relates to other things. And we will declare victory. We will say, like, this is it. That's what you meant by saying, oh, yes, I'm sad. Like, this is what is happening in your brain when you're sad. And I can make it happen. You don't need to bring up a memory of that awkward moment at your senior prom. I can zap electrons into your brain in the right ways, and you'll be sad also. And I think that we'll just be appreciating more and more that the brain is a physical system just like anything else.
I was going to ask you what your escape route out of dualism was with that, but you answered it. You are a physicalist, which,
Yeah, that's right.
Right. Physicalism, idealism. And then I guess there's another one, which is, I can't remember the name of it, but you just think it's all one thing, that it's simultaneous.
There's a long list of isms. So, idealists think these are terrible names because they have other meanings, right? Idealists are not like starry-eyed optimists. Idealists in this sense are people who think that mind precedes physical existence, right? That all of what we call the real world is a projection of mind somehow. And I say mind singular because some of them think that it's a projection of all the individual minds and individual people. Others think that there is one mind from which all of reality comes. And, they have a lot of fun trying to fit quantum mechanics into this way of thinking. And I think it's misguided, but it happens. There are physicalists like me who think it's stuff everywhere, right? There is stuff, and the stuff does different things. And then we attach labels to the stuff doing things that we call people and planets and consciousness and all those things. In between, there are people who are what David Chalmers, how he would describe himself, he is a property dualist, but not a substance dualist, okay? So there are dualists who think that there are both mind and body. There's both stuff, the body, also the particles, the stuff of physics, and there is a mind, a separate thing. That's what Descartes would have said, right? So that's in between idealism, who thinks mind only, physicalism, who thinks stuff only, a substance dualist think there's two different kinds of substance at the same time. Chalmers thinks that the stuff is all physical, that the universe, the real world, is made of particles, just what the physicists think. But in addition to the physical properties of the stuff, there are also mental properties of the stuff. So when you tell me an electron, you tell me its mass and its charge and what it's doing quantum mechanically, all of its physical properties, he says you're not done describing it. There are also mental properties that electron has, and you can see how this leads you to be a panpsychist.
It's interesting. For, I would say, the last 15 years of my life, basically since I was a little kid, I have been an atheist person, and so, but recently, and I feel like this is because I just need to acknowledge that I don't know things, that I should stop saying that. And I feel like, I'm not a religious person in terms of, like, I don't subscribe to any denomination or anything like that, but it is very difficult for me to square things sometimes when it comes to lifetimes, the fact that there is a finite nature to life in general and our perception of the universe. And I don't know how to really explain that through purely physical terms, what the quality of the experience is and how to square the subjective conscious experience with the fact that the universe will continue when I'm gone, even though I will have no observation of it.
Yeah, these are legitimately tricky things, and I sympathize with people who care about these questions, whatever their answers might be. I think, and again, this is a two things are true at once situation for me. On the one hand, we don't know all the answers, and it's important to recognize we don't know all the answers. In my book, The Big Picture, I talk about these issues explicitly. I talk about Bayesian reasoning and how you should assign probabilities to things being true. And those probabilities should never be 0% or 100%. They should always be, they can be 0.0001% or 99.999%. But if it's 0 or 1, then reasoning breaks down because that means that there's no evidence you can ever get that would change your mind, no matter what. So you always need that tiny little fraction of a probability that you're wrong. That's crucially important. On the other hand, so at the same time, I think that the probability that your personal credence that you're wrong about a certain issue can be so small that you shouldn't worry about it, right? I'm pretty high credence that the sun will rise in the east tomorrow, okay? At least that it won't rise in the west. Now, I could be wrong. It might not rise in the east because the sun explodes or a black hole eats it up. I'm not sure why it would ever rise in the west, but it's possible, I suppose, right? But I'm not going to worry about it. I'm going to go through my life pretty sure that the sun rises in the east. And if someone wants to have a long, detailed conversation about the pros and cons of the sun rising in the east, I'm going to say, I don't have time for that. I have other things to worry about. And I think that's a perfectly legitimate attitude to have.
So you mentioned Bayesian reasoning, which is the opposite of what most people do, which is kind of read and react, right? You just kind of make a determination and it's absolute that
Well,
determination.
yeah, I mean, I think that Bayesian reasoning is a way of reasoning in states of uncertainty, which are basically the only states we're ever in. So Bayesian reasoning is a way of saying, for any set of possibilities, who's going to be the next president, what should I have for lunch, what was my birth date, whatever, any proposition where there could be different possible answers, you assign probabilities to every possible answer. Some of them might be big, some of them might be small, but you admit that you're not sure. Like, even though I think I know what day I was born, okay, but maybe people have been lying to me my whole life, or maybe I misremembered. It's a tiny probability. And then the other part is there's a set of tools for updating your probabilities when new evidence comes in, when you learn something new about the world. So, the example I give in the big picture is, you want to know, you're in high school and you have a crush on someone and you want to know, like, do they like you too? And so, you have a certain probability. They like me, they don't like me. And then you have an encounter with them in the hallway and you say hi. And depending on whether or not they ignore you or they stick around to talk with you, your probabilities will change on whether they like you or not. And so this is a formal mathematical framework for discussing all of that stuff and making it happen in a rigorous way.
I think one of your first appearances on the Joe Rogan podcast, you talked a little bit about your life philosophy and, just kind of how an acceptance of, my life's going to end eventually. There are certain difficult problems that the universe presents you, and you have an amount of time to solve the problem, and you're going to do your best to solve the problems while you can, which I think is a very interesting way of, I don't think a lot of people look at their lives that way as a young person. They're kind of just at the whims of the things happening around them a lot of times. They don't really look at it, the universe or their lives in terms of problem solving, and then this is the way that it is. I when I heard that, I thought in my head of the phrase, we kind of live in an infinite prison. There's you can go infinitely in any direction you want to in
Yeah.
physical universe, and there's going to be a problem. You can go down. I think Richard Feynman said this. You could learn thousands of different languages of names of a bird and still not know anything about the bird. So that calling a thing is different than knowing a thing, and that
Yeah, I do.
Yeah,
I
go
do
ahead.
think that this fact that our lives are finite is crucially important, and one that as a society we don't do a very good job of facing up to. And you're probably right that young people have a more difficult time. Look, when you're in your 20s, for that matter, when you're in your teens, right? You're on the one hand, you're contemplating your life in a serious way that you're not when you're 5 or 6, right? You're thinking about, like, where to go to college, what job, what was my profession going to be, am I going to get married, etc. But the idea that you're going to run out of your life is just not imminent to you, right? Like, you think, I have plenty of time, right? And let's face it, I'm 53 years old. I am very, very likely over halfway done with my life, right? That's what the demographics, whatever it is, whatever the word is that I'm missing, but the likelihood is that I've lived more than I will live in the future. So you begin to think, well, all right, it's a little bit more precious now to make the right choices. I better, I don't have infinite time in front of me, and that's fine. It's it's not even fine. It's like there's no choice. It's not like I can argue against it or complain about it. But then the question becomes, what are you going to do about it? And I'm very pluralistic and subjectivist when it comes to deciding what to do with your life. I am not someone who is at all comfortable telling other people how they should live their lives or how they should bring meaning to their lives. I might suggest ways that you could do things that bring meaning to your life. But if someone would be happiest doing nothing but playing video games or tending their garden or there's a million different things people can do. Building the biggest ball of yarn in the state of Wyoming. I can't judge them, like I can say that's not what I want to do. But if that is what is most fulfilling for them, then that is something that I think is not objectively wrong. I think it's a choice that they're making. All I would ask is that people understand the choices that they have. They don't fool themselves into thinking, untrue things about the universe, which I would include life after death in. And therefore, they make choices about this life that are, in line with the facts about what's going to happen to us.
This is kind of unrelated to the physics questions necessarily, but I know that you are I don't know what the right way to say it, because I don't know exactly what your relationship with Richard Feynman was, but
I never met him, so didn't really have one.
Yeah, so, but he has influenced a lot of the way that I think about things. And I wonder how much he's influenced you, because I haven't really met a whole lot of people who knew or know who Richard Feynman is.
Well, Richard Feynman was a brilliant physicist, but to any of these questions, I always say, like, I'm very against having heroes. I'm even kind of a little bit against having role models, to be honest.
Sure.
Or at least what I would like is, if you have a role model, for a particular field, right? Like, I can say that Richard Feynman was a brilliant physicist, and I would, like to be as good a physicist as Richard Feynman. Okay, that's a perfectly good goal to have. But the idea that because he's a good physicist, he's a good person, that I think that there's zero evidence that you should do that. I would say the same thing for, a religious leader or a popular singer or a politician, just because they're good at one thing. A writer, an actor, right? We, especially with celebrity culture, we tend to get caught up in these people. We look up to them, and then we're disappointed when we learn something terrible about them. Sure. And that goes for scientists and professors just as well as anybody else. So rather than telling people, like, here is who I look up to or anything like that, I think I would really love to shift the conversation way in the other direction and say, like, find things admirable in people, but don't hold them up, especially if you don't know them. Like, if you know somebody and see them day-to-day basis, then you can know enough about them to admire them as a person. But if you've never met somebody, you better not be admiring them as a person too much. Or you're setting yourself up for disappointment.
Yeah, maybe this is just a byproduct of your field, but he was really good at explaining complex concepts. And I feel like you're very good at explaining complex concepts. And I appreciate that, because, Richard Feynman died before I was born. So I did not get an opportunity to ask somebody like him questions. And you are extremely accessible when it comes to people like me bothering you on the internet and then asking you all these questions about the universe that not that I demand answers to, but I really would like to know. I have an itch for this stuff.
Well, I think that different people, again, have different choices that they're going to make about how much they're going to focus in on their particular thing and how much they're going to spread widely different kinds of things. I'm very happy to admit that my personality is such that I would be unhappy if I were just doing the same thing every day. So part of me, doing outreach or writing books or something like that, is not that I like that more than I like doing physics research. In fact, if I were forced to only do one thing all the time, it would be physics research. But I'm not forced to do one thing all the time. I have the ability, the freedom, the privilege of doing a little bit of this, a little bit of that. And that's what makes me happy. So, it's my personal way of doing life that I enjoy, both reaching out to wide sets of people, to teaching and having students, and also doing research and publishing new papers. But I don't begrudge people who are my physics colleagues who don't want to do that, there are people who only want to sit in their offices and do theoretical physics research. There are people who I did some research, but I'm kind of tired with that now. I'm going to concentrate on teaching or outreach or anything like that. I have enormous respect for all those people. I don't think you can force individuals to do everything, but I like doing everything. That's my thing.
That's a great way to end it. Thank you very much for this last hour. This has been so much fun for me. I've really enjoyed this. I hope you enjoyed yourself as well.
Sure, TJ. Yeah, it was a lot of fun. Thanks for having me on.